everyone. So my topic for discussion today will be on choosing an appropriate statistical test of significance. Now, looking at the statement itself, it will be like Greek and Latin for most of you. I do understand because I had also been in the same state last year. So my talk will help in understanding how to select a statistical test for testing a null hypothesis. So Sir had mentioned about null hypothesis numerous times. And along with this, I'll also be giving an insight on what are the parametric and the non-parametric tests, the types of data, and a gist about paired and unpaired data. So these will be the main core areas that I will be covering this evening. So the only concern was during our MBBS days, most of us during our community medicine postings either skipped classes for several reasons, games, movies, and family ceremonies. Problem is, most of us missed all these topics, and now it is haunting us both in our theory and practical exams. So I prepared the slides in such a way it will be as crisp and as basic as possible, and it will give you an insight what needs to be answered also from an exam perspective. So another add-on is tests of statistical significance, types of data, and parametric and non-parametric tests all have been asked as short notes. So usually statistics questions are asked like two-part questions. So in that one part has been related to one of these questions. So it is important to have a overview of all these areas. So before I go into the topic, just you know, a study. Do a hypothesis testing process. So we have a problem to be defined. Like example, we have a thought process whether smoking causes cancer. So based on that, we then proceed for further testing. So we state the null and the alternate hypothesis. So the null hypothesis is denoted by HO and it states that there is no statistical difference and there is no relationship between the variables, that there is no relation between smoking and cancer. Whereas there is also a alternate hypothesis that needs to be made. So that actually contradicts the null hypothesis. So once this null and alternate hypotheses are stated, then you need to identify the appropriate statistical test, which you will consider once you have collected the sample size. So you would have made a plan, you would have made a assumption, you would have collected data. Then once you collected data, make a master chart, then you have to identify the appropriate statistical test. Then you have to specify the level of significance. So once that is done, you interpret the results. And finally, you make decisions. So the area that I will be covering is predominantly identifying the appropriate statistical test. So how do you do it? So there are actually 5 areas you need to concentrate on. So I've tried to make it as simple as possible. The first question is, in your study, you check whether there is a comparison between two variables. That is, you are comparing a difference or you are assessing for a relationship between two variables. So that is the first thing you need to look into. So I'll repeat it again. The first question is you either have to compare a difference or you have to check for a relationship. The second is you have to assess the scale of the data that you are checking for, whether it is a continuous or a numerical scale, an ordinal scale, or a nominal scale. I will discuss about this in the next slide. Then the assumptions of the parametric test, whether it is suitable for using a parametric test. That also I will discuss subsequently. And assessing the experimental design, whether the data are paired data or unpaired data. And last is the number of groups that you are assessing, whether it is one group, two groups, or more groups. So when you're selecting ideal test of significance, you need to look into these 5 areas. So just for revising, the first is you have to assess the question whether you are comparing. Sorry, 1 second. I'll just check. The signal is breaking. 1 second. Am I audible now? Okay. So when you're selecting an ideal test, you have to look into 5 areas. One is the question. First, you assess whether you are looking for a difference between two variables or you are assessing for a relationship. Second, you see the scale of the data, whether it is a continuous data or an ordinal data. Example, mild, moderate, severe, good, better, best, bad, worst, worst, those kind of things, or nominal, male, female, uh, young, old, those kind of stuff. Then assume for the parametric test, which I'll discuss subsequently. Then you assess the experimental design, whether it is a paired or an unpaired data. And the last one is you assess the number of groups that you are testing. That is the number of groups and sets that you will be looking into, whether it is one group, two groups, or more groups. So the first one is you assess whether you are looking for a difference between two groups or you are assessing for a relationship between two variables. So example for assessing for a difference between two groups are, one is you assessing for difference in BP in individuals before and after exercise. That is the easiest example that can be given. Or you are comparing two fertilizers for plant growth. That is before giving the fertilizer and after giving fertilizer, you are assessing how the growth of the plants are. So this will give an idea about the relationship, the difference between the variables. Whereas if you're going with a relationship between two parameters or two variables, the examples can be relationship between BP and BMI or height of a plant and the amount of fertilizer used. Here we had mentioned about two fertilizers for plant growth, but here we are assessing the height of the plant and the amount of fertilizer that has been used. So the graphs that are formed are the linear regression graphs that are seen over here. So that will give an idea about the degree of relationship that is between these variables. So when you're initially looking for the question, you need to assess whether there is a difference between the two groups or there is a relationship between the two variables. That is the first question that you need to satisfy. Second, you have to see the scale of the data. Now, this data per se itself is a short note. So I made it concised into one slide. So data can be classified into qualitative data, that is categorical, or non-numerical data, and quantitative data, that is numerical data. So quantitative data can be discrete and continuous. Now, what is discrete and what is continuous? Discrete is they have a finite number of possible values and they tend to be made up of whole numbers. Example, the number of students absent each day at school. On day one, there could be 7 people who are absent. Day two, 13 people. Day three, 3 people. And day four, 4 people would have been absent. Whereas continuous data have infinite possibilities because they include decimals also in their variables. So example for that can be diameter of a tumor, that is 1.23, 1.78, 2.25. The list can keep going on. Whereas for qualitative data, it is non-numerical. Like example, like I told, gender, female or male, outcome cured or not cured, like that. So this is one table I had made for easy remembrance before the exams. I had taken this from this book called Past Test Guide for Biostatistics. So here the scales for data are classified as nominal, ordinal, and continuous comes as intervals and ratios. So the difference between these data types are, it goes based on these 4 factors. So we assess whether it shows a difference. If there is a difference between the data, it will be present in all 4 of them: nominal, ordinal, interval, and ratio. But the direction of difference will not be present in nominal because you're looking only in 2 areas, either whether they're male or female or cured or uncured. So there is no concept of direction of difference in these groups. Whereas in ordinal, you do have a direction of difference. Maybe they were better, but they could have gone to good or they could have gone to best. So they could have gone one step up or they could have come one step down. Similar is for intervals and for ratios. And the amount of difference that is shown between the data that cannot be assessed with nominal or ordinal data, but with intervals and ratios it is possible, because intervals, like example I've given, from -40 to +40. So if any value is there, you can subtract it from the mean and from the middlemost median number, and you can assess for a difference. Similar is for the ratio. So the next important difference is between interval and ratio. The only difference is ratio has an absolute zero. Absolute zero means the variables start at zero and then move positive. So it will have 0, 20, 40, 60. Whereas interval has a negative and a positive from -40 to +40. So these four scales of data can be classified based on these parameters. That is the ability to show difference, the direction of difference, the amount of difference that is shown, and whether that has an absolute zero. So these are the four areas that need to be looked into. So I think I'm kind of clear, because one thing I really want you all to look into is nominal and ordinal data, because these two are important aspects that will be looked into when we make the final statistical set algorithm. So nominal, ordinal, and continuous data. So nominal, as I said, it is categorical, non-numerical, it has gender, which can be male or female. Ordinal is rank-based, good, better, best, mild, moderate, or severe. And continuous can be either interval or ratio. The important difference between both of them is the absolute zero. Ratio starts from zero and moves forward, whereas interval can start from a negative point and can move till a positive point. So there are market variations. So we saw two areas. One is whether there is a comparison, that is, there is a difference between two variables or a relationship. The second thing is we assess the type of data. And the most important data we are looking into are the nominal data, the ordinal data, and the continuous data. And continuous data, you are looking into intervals and ratios. The only difference between two of them is the absolute zero is present in ratios. So the next important thing is about parametric and non-parametric tests. So before going into this, just make look confusing. So this area, this is parametric testing. So parametric tests assume that the population distribution is normal or has a specific shape and parameters like means and standard deviations. Like this, it has that typical bell curve which Tapas sir had mentioned in his presentation. And parametric tests rely on statistical distributions in data. So these are the two important points while making up the definition for a parametric test. So I'll just repeat it. Procedures assume that the distribution is normal or has specific shape and parameters like means and standard deviations. And it very importantly relies on statistical distributions. Whereas non-parametric tests make no or few assumptions about the population distribution. So as I mentioned here, parametric tests, they are based on a normal distribution. They are quantitative. That is, they are based on continuous data, which can be either intervals or ratios. Like I said, ratios will have an absolute zero. Intervals will have from negative to positive. And they compare means and standard deviations, and the main values that they take for consideration, that is the central tendency value, is the mean. The main advantage of a parametric test is they are more powerful. So what does more powerful mean? It is they are less likely to make a type 2 error. So as Tapas sir presented in this previous presentation, I'm just making it just for a memory recall. I'm just mentioning here. Type 2 error is a false negative, where even though the null hypothesis was false, it failed to reject the null hypothesis. That is the type 2 error. So for parametric, important assumption that needs to be made, it should be a normal distribution. Data should be quantitative, that it should be numerical data. the scale of measurement should be interval or ratio. We compare the means and standard deviations, and the references that it takes for its measurement is based on the mean. And it is supposed to be more powerful than the non-parametric tests. So coming to the non-parametric test, it is mostly a skewed distribution. That is, it is the skewed distribution is the opposite of a normal distribution. That is, it is not normally distributed. And it depends on qualitative data, that is categorical data, which can be nominal or ordinal. And it includes percentages, fractions, and median. And the main value it looks into for its variable assessment is the median. And it is supposed to be less powerful than the non-parametric test. So this is the normal distribution curve, which you had seen in the previous presentation. So if the data is distributed like this, it can be well thought about for a parametric test. But if it is either this side or this side, that is, it is A or C, it is skewed data. So skewedness is the measure of asymmetry of the probability distribution of a real value random variable about its mean. Very simple to say, when everything lies like a bell, that is all the mean, median, mode are in the same line, it is a normal distribution. Whereas if it is either more shifted to the right or to the left, then it is a skewed data. So this alone needs to be kept in mind. So we looked at the first question. You compare the differences between two variables or assess a relationship. Then you looked at the types of data, whether it is nominal, ordinal, or continuous. Under continuous, you looked at intervals and ratios. And the third thing is you looked into parametric and non-parametric. So parametric assume distribution of population under a normal curve, that it is a very uniform distribution. It looks at quantitative data. The scale of measurement is mainly of intervals and ratios because it is mainly numerical, and it mainly takes into account the mean, and it is more powerful. Whereas non-parametric is based on skewed distribution, it is qualitative. The scale of measurement is nominal or ordinal, and it compares percentages, proportions. The main factor that is looked into assessment is the median, and it is less powerful. So these are the first three questions that we have addressed. So the next question is assumption for parametric test to be satisfied. The two things that we need to be looked is you assess whether the variables are normally distributed. Like I saw in the previous slide, if the distribution is almost like a bell distribution, you can be well assured that it's going to be a parametric data. So it will have more power and the less likelihood of a type 2 error. So the type 2 error is less, the validity and the generalizability is going to be good. And the second thing we need to look into is there are lots of times when the data can be skewed because the sample size may be less. But in those cases also, parametric testing can be done. It may sound controversial to what I'd spoken in the previous slides, but they say if it is a skewed data, you can go for parametric testing provided your sample size is more than 30. That's why I've mentioned over here, if it is more than 30, you can go ahead with skewed data, but otherwise with the normal distribution, it has more power. So the next area that needs to be looked into is whether the data are paired or unpaired data. So we have covered four areas. One is the comparison between two variables or a relationship, the types of data, parametric, non-parametric, then the assumption for parametric, whether it is a normal distribution. In case it is skewed data, the sample size should be more than 30. So the last part is about the paired or unpaired data. So paired sample, what is a paired sample? See, paired sample is very simple. You have one subject. From that one subject, you take two measurements. Like example, a person has hypertension. You assess the BP before giving an antihypertensive, and you assess the BP after the antihypertensive, and you document the findings and do your testing. So that is one way of looking at it. Or another way is you assess the scores of candidates before and after a class was taken. That is like what we do in our AHA, that is pre-test and post-test, to look for a difference in the performances after the class is taken. That is to assess how good the class was. The third example that me given is each cat can be provided with two varieties of cat food to assess which is more appealing. So whichever the cat goes has a more craving for, that can be taken as the endpoint. So in all of these, the measurements are taken twice. So one thing I wanted to emphasize is because I got this image from one of the websites. So with cat samples, you have the same subjects, but you have two variables. That is, they would have taken two cat foods and you assess the appealability. And based on that, you do testing. Similarly, you can do it even for the other two examples that I've given. So for paired data, you just have one sample, but you do two measurements. Whereas for unpaired or independent sample, there are two groups with no relationships between people in one group and people in the other group. Example, comparison of scores between candidates who have gone for face-to-face tutoring versus online teaching. Or cat food varieties assigned between two groups of cats and assessing for the appealability. So here you can see there have been a number of cats who have been given one type of cat food and another type of cat which has been given another type of cat food. So then you make a table of two different cat food and two columns of two different cat food and you collect the data accordingly. So this is how paired and unpaired data. So just to summarize, paired data, one sample, two measurements. In unpaired data or independent sample, there are two groups. The samples in between these two groups have no relationship between each other. So that is the important things to look into. And the last one is the number of variables you are looking into, one variable, two variables, or more variables, because the testing will change accordingly. So we have all assessed the 5 questions. First question is assessing for a difference between two variables or assessing for a relationship between two variables. Next is assessing the data, whether it is a qualitative or a quantitative. If it is qualitative, it is nominal. Whereas if it is quantitative, it can be classified as ordinal, that is rank based, mild, moderate, severe, or continuous data, which can be discrete or continuous, infinite. So in that you have classification of interval and ratio. The only difference between those two is the ratio has an absolute zero. That is, it starts from zero and it moves forward. So that is question two that was answered. Third is parametric tests. Parametric tests have a normal distribution assumption. It uses the mean as its main mode of assessment of the variables, and it is more powerful. That is, it has less likelihood to produce a type 2 error. Similarly, non-parametric is used only for qualitative data. It is less powerful and it uses the median for its assessment because of the skewness. Then for assessment of the parametric test, the important thing to look into is the normal distribution. And the second thing that you need to look into is the skewness. If skewness is present, then the sample size needs to be more than 30 to make it as a parametric testing. Then the fourth one is for assessing paired and unpaired data. In paired data, you have one subject who is being subjected to two measurements that can be pre-test or post-test or pre-drug, post-drug, etc. And in unpaired or independent, you are assessing two groups who are totally unrelated to each other for a common outcome. And the last one is the number of variables that you are checking for. That is, whether it is one variable age of a person, example. So based on these 5 questions, now we come into the algorithm. So you have first assessed whether there is a difference between two groups or whether there is a relationship between two variables. So the first question we have looked into. So next is you assess whether it is continuous. That is, it is numerical based, whether it is intervals or ratios, or whether it is ordinals, that is rank based, that is mild, moderate, severe, good, better, best, bad, worst, worst, or it is nominal, male, female, cured, uncured. So if it is continuous, then you make an assumption for whether the parametric test was satisfied. That is, whether that is a normal distribution or if it is skewed, or if it is skewed, the sample size is more than 30. If it is yes, then you assess whether it is paired. Paired means you do once in one subject, you do two measurements, those kind of studies. Or you assess if it is unpaired, whether it is two separate groups that you are assessing for an outcome who are totally unrelated to each other. If they are paired, you assess if it is two groups. If it is two groups, the test that you need to do is a paired t-test. Whereas if it is more than two groups, you do a analysis of variance test. That is the ANOVA with repeated measure. The details of these talks will be further emphasized in the subsequent discussions, but I just want to make it clear for what indication we do this testing. So if it is a continuous data, parametric test is satisfied, it is paired, and it is two groups, you go for paired t-test. If it is more than two groups, you go for ANOVA with repeated measure. Whereas if it is unpaired data, but the parametric test assumption has been satisfied, then you go for unpaired or independent t-test. And if it is more than two groups, you just go with the one-way ANOVA. So the easiest way to understand these two is in paired, you go with one subject and you do two measurements. So if there are more than two groups, you do an ANOVA and you do repeated measurements. So that's why here it comes as ANOVA, the repeated measures, and here it comes with one-way ANOVA. So that is the easiest way to remember it. The next one is under ordinal data, or if the parametric test assumption has not been satisfied, that is the sample size for skewness is less than 30 and the distribution is not normal, then you need to look into it as an ordinal type of distribution. Under that, you assess whether it is paired or unpaired. So if it is an ordinal data, that is, like I said, rank based, good, better, best, mild, moderate, severe, and it is paired. That is same person, two measurements. You assess if it is two groups. If it is under two groups for a paired data, you go with Wilkinson's signed rank test. That's why I was always correlating ordinal with rank. So this is one of the best way of remembering. If it is paired with the two groups, you go with Wilcoxon's signed rank test. Whereas if it is more than two groups, you will have to go with the Friedman test. Similarly, if it is an unpaired data and it is ordinal data set, you assess if it is two groups. If it is two groups, you go with the Mann-Whitney U-test. And if it is more than two groups, you go with the Kruskal-Wallis test. All four of these tests will definitely sound like foreign languages, but for theory perspective, it's better to write it in a piece of paper and memorize it every day so that before the exams, you will have an idea at least. So the next is we have covered continuous and ordinal. So next is nominal. Nominal is categorical data, that is male, female, cured, uncured. So under that, you assess whether it is paired. That is same person, two measurements, or two separate groups are being assessed. So if it is paired or unpaired, if it is paired, you go with the Mech-Nemer test, and if it is unpaired, you can go with the chi-square test. And if it is just a single category that you're looking into, that is just one component like age, or you're just looking into the sex alone in your study master chart, then one sample proportional test alone will suffice. So these are the tests that can be done in cases there are assessment for difference between two groups. The next one is for assessing the relationship between two variables. So under that also, you can classify it as continuous, ordinal, and nominal. So under continuous, you make an assumption for the parametric testing. Like I said, first one is the difference relationship variable. Then you assess the data set type. Then you assess whether it is parametric or non-parametric. Then you assess whether it is paired or unpaired. But when you do a relationship between two variables, you don't really need to look into the paired or unpaired data. So that is the only what do you say trick that you can keep in mind. So if the relationship between two variables, the data is continuous, it is parametric test assumption positive, then you go with person's correlation or linear regression. Whereas if it is a non-parametric test or it is an ordinal data, that is rank-based data, you go with Spearman coefficient. Whereas if it is nominal, irrespective of whether you're doing it between, it has a difference between two groups or a relationship between two variables, you have just two tests that we need to look into. If it is paired, you go with McNamara test. You can remember it as a mnemonic PM, Prime Minister, paired and McNamara. Similarly, unpaired can be chi-square test. Chi-square test is one test we all frequently hear about, chi-square, t-test, and ANOVA. So these are the areas where these tests are usually implicated. So I think this is an overview which is being simplified as much as possible. So this should fetch you at least 3 to 4 marks easily. So one thing is, why can't I use a t-test instead of an ANOVA, or why can't I use a chi-square test instead of ANOVA? All these thought questions usually came to my mind when I was preparing for statistics during my theory exam, because I had completely no idea about it. But when I looked a little in depth into it, each of these tests have separate formulas, as you can see over here. So you apply one test for another set of variables, your overall outcome is not going to be accurate. So if it is not going to be accurate, your statistical testing is not going to be valid. And that is going to interfere with your results, creating an increased risk of a bias. So the more bias it's going to produce, the more error and the clinical applicability is going to get affected. So from all these perspectives, you need to be very particular in which test you are going to look into. So that is the importance of these statistical tests of significance. So just for a revision sake, 5 areas you need to look into is: first, you assess for a difference between whether you are assessing for a difference between two variables or you are assessing for a relationship between two variables. The next thing is you assess the type of data, that is whether it is a qualitative or quantitative. Qualitative is also categorical, example male or female, whereas quantitative is numerical. It can be finite or infinite form of decimals, and it can be classified as either ordinal, which is rank based, mild, moderate, or severe, and it can be intervals and ratios. The only important difference between both of them is ratios have an absolute zero. That is, the data starts from zero and moves forward. So once you assess the question on comparison, the data, next is assessment of parametric and non-parametric testing. Like I said, for parametric, it has to have a normal distribution in its assumption. Then it takes mean as the main variable for its calculation. Then it has good power, that is less likely to produce a type 2 error. All of these opposites will occur in a non-parametric test. So in non-parametric test, there will be a high degree of skewness. Because of the skewness being present, you cannot use mean. You will have to use median as your central tendency of measurement. And after that, you have to assess the assumption for the accuracy of parametric testing. So for that, you have to assess whether the distribution is normal. And if it is good, you have to assess if the sample size is more than 30. And the last one is you assess whether the variables you are looking into are a single variable or two variables or three variables. Like example, age, weight, sex, all these three factors you are looking into, or you're just looking at the age and height, or you're just looking at the age and weight, or that is like two variables. So based on that, like I said in the previous, these are the tests that you can look into. So t-test is one question that can be asked. So if you mention this flow chart of how you will approach for a t-test, it will get you a good amount of scores. Plus, I think Darshan will be also talking on t-test. So when he covers on that, those points also can be added on. This Wilcoxon signed rank test, Friedman test, Kruskal-Wallis test, Mann-Whitney test can be taken like a screenshot on your phone and looked into every day, because 100% you will not remember it before the exam unless you keep remembering these terms like a song. Person's correlation, linear correlation, and Spearman coefficient. Eventual talks, there will be discussions on that. So you will have a mild idea on those areas also. So, and as like I said, why one test for another, each test has a different formula. So during our community medicine days, we have never been exposed to this area at all. So we do not know about it. But when I looked into these factors, I felt that this was one of the reasons why they say you are not supposed to use use one test for a specific subset of patients. Like you cannot use unpaired in a paired test, unpaired test in a paired set of patients, or test for an unpaired set of patients.